Cases of equation, multiplication, addition, and subtraction. So this video is going to be about matrix math problems that are in equation form. So which means while it may involve multiplication, addition, subtraction, but at the end of the day we're going to arrive at equation and we're going to solve until we get the values of x and y. So this video is concerning such cases. So let's take examples. Now one says if a is plus 1, 2, 3, 4, and b matrix b is minus 3, 1, 2, 4. Find c such that AC is equals to b. Okay, now this is an equation form. In other words, we can say c is also another matrix that when multiplied by a will give us matrix b, but we have to get the entries or elements of matrix c. So we're going to represent let's c equals to a, b, c, d. Elements a, b, c, d, or entries a, b, c, d. Okay, so now let's move on. So a, c is equals to b. This was what was given to us. So we're going to say our a is 1, 3, 2, 4, and our c is a, b, c, d, and we told that matrix b is equals to minus 3, 2, 1, 4. So we're going to multiply 1 times a will give us a plus 2 times c will give us 2c. Okay, 1 times b will give us b, 2 times d will give us 2d, 3 times a will give us 3a, and 4 times c will give us 4c, 3 times b to give us 3b, plus 4 times d will give us 4d, equals to minus 3, 1, 2, 4. At this point, we're going to equate entries, or say equating row, either equating entries a plus 2c equal to entry a11, which is a11 here. Equating rows or entries, we're going to have a plus 2c equals to minus 3, 3a plus 4c equals to 1 on one side, let me see, and okay, so let's call this equation 1, let's call this equation 2. We have here b plus 2d is equals to 2, equation 3, and then 3b plus 4d, equation 4. So what we can see, equation 1 and 2 have the same variables or constants. So let's solve for a and c. That's equation 1 and 2. Form 1 and 2. 1 and 2. So from 1 and 2, we're going to solve. This will give us, let me eliminate a. So we multiply equation 1 by 3. This will give me 3a. So I'm using elimination method. So since I'm going to eliminate a, I'm going to ensure that the two sides have their 3a. They are all, this side is 3a and this side is 3a. Then I'll subtract, thereby eliminating a out of the equation. Then I'll have just a constant c to solve for. So I'm going to multiply equation 1 by 3 so that here will be 3 as just as s to the a. So 3a 6c is equals to minus 9 divided by 1, 3a plus 4c is equals to 1. Let's subtract. So 3a minus 3 is equal to 0. 16 minus 4c is 2c. Minus 9 minus 1 is equal to minus 10. And c is equal to minus 10 over 2. C is minus 5. C is minus 5. Okay, so since we are still working with equation 1 and 2, and we've gotten A only, let's get C. Substituting the value of C into equation 2. We're going to have equation 2 is 3a plus 4c is equals to 1. So our C is minus 5, so 3a plus 4 minus 5 is equals to 1. 3a, 4 times minus 5 gives us minus 20 is equals to 1. So 3a is equals to, collect like terms, 1 plus 20, 1 plus 20. So 3a is equals to 21. And a is equals to 21 over 3, which is equals to 7. So a is equals to 7 and c is equals to 3. So from equation 3 and 4, equation 3 and 4 have same terms, d and b. So we're also going to solve using the elimination methods. Okay, so this is a Martinez equation, so we're going to solve using elimination method. So since it's 3b, let me also eliminate b. So I'm going to multiply equation 3 by 3 times 3. That will give me 3b plus 6d is equals to 6d. Okay, then equation 4 is going to be multiplied by 1. This is 3b plus 4d is equals to 4. We have subtract 3b minus 3b is 0. 6d minus 4d is 2d. 6 minus 4 is 2. So d is equals to 2 over 2, which is equals to 1, and d is equals to 1. So substitute the value of d into equation 4, where we are going to get the value of b. So 3b plus 4 1 is equals to 4. So 3b is equals to 4 minus 4. 4 times 1 is 4. Carry it over to the side because they are like terms. So 3b equals to 0 and b is equal to 0. 3 and b is equal to 0. So from what we've gotten, let's see, and come here. Therefore, a is equals to 7, b is 0, c is minus 5, and d is equals to 1. So remember the matrix. Question says find C such that AC is equals to B. So let's get our matrix C. We initially use the letters A, B, C to represent matrix C. So let's get the matrix C that has the values instead of letters representing values. So matrix C, which is C, is equals to look at matrix C. A here is 7, and our B is 0. Our C is -5, and D is 1. So this is the matrix C. So this matrix, when multiplied by matrix A, will give us this matrix C. When multiplied by the matrix A, AC, will give us the matrix B. That's what the equation is all about. Number 2, it says solve the equation 2, 1, minus 3, 3x, y equals to 1, 2. So we're going to multiply this matrix by this matrix and equate it to this matrix. Then the resultant equation we're going to solve until we get the values of x and y. The 2 times x will give us 2x minus 3 times y minus 3y. 1 times x, x plus 3 times y, 3y. This is equals to 1 and 2. So 2x equating rows or entries. So this entry is the first entry is equal to this entry. So 2x minus 3y is equals to 1. Equation 1. X plus 3y is equals to 2. Equation 2. So solving simultaneously, I want to use the substitution method this time around because in previous videos I've always been using the elimination method. So this time around I want to use the substitution method, but you can still use the elimination method if you want to. You are still going to arrive at the same answer. Solving simultaneously using the substitution method. So since we are substituting, we're going to, say from equation 2, which is this equation, make x the subject formula. Make x the subject formula. So this will give us x plus 2y is equal to 2. So to make x subject formula means we need to eliminate 3y from here. This will give us, that means subtract 3y from both sides. 2 minus 3y plus 3y minus 2y will be 0, so x will be left here. This will become our equation 3. So now that we've gotten equation 3, we're going to substitute or put 3 in place of x in equation 1. Put equation 3 in place of x in equation 1. Because from equation 2 we got equation 3, so I'm going to put equation 3 in place of x in equation 1. So this will give us 2. So where we have x, we're going to put this value that we have got for x. 2 minus 3y, minus 3y is equals to 1. So 2 times 2 is 4. And 2 times minus 3y is going to give us minus 6y minus 3y is equals to 2. So the next thing we're going to do is to collect like terms, meaning that the terms that are alike, we bring them together. So we see collect like terms, So this minus 6 minus 6y minus 3y is equals to 2 minus 4. So 2 minus 4, is it 2? This is 1. No, 1. It's not 2, it's 1. 1 minus 4, because here's 1, and we put 3 in place of x in equation 1. Equation 1 is 1, so it's not 2. So now let's proceed. Minus 6 minus 3 is going to give us minus 9y. 1 minus 4 is 3. So y is equal to minus 3 minus 9. The minus sign is going to cancel out. 3 here, 1, 3 here, 3. So y is equal to 1 over 3. Substitute the value of y. Substitute the value of y into equation 2, which is this equation. So x is equals to 2 minus 2y. Remember, y is 1 over 3. 2, 1 over 3. So x is equals to 2 minus 2 times 1 is 2 over 3. Now we have a fraction to deal with. So make it to be 1. Why we do so is because 2 is equal to 2 over 1. So we put this in place of this here. So now we have a fraction. So we're going to get the LCM of the two denominators. LCM of the two denominators is 3. 3 divided by 1 is 3. 3 times 2 is 6 minus 3 divided by 3 is 1. 1 times 2 is 2. So 6 minus 2. 6 minus 2 is 4 over 3. This also have 4 over 3. 4 over 3. Oh, yes, x is 3y. And I put 2 here. X is 3. So that means coming back. So x is 3. So 2 minus 3 times 1 is 3 over 3 over 1. So proceed. We can proceed right away from here. 3 divided by 3 is 1. 2 divided by 2 over 1. 2 divided by 1 is 2. So 2 minus 1 is equals to 1. Or we solve the fraction. The LCM of 3 and 1 is 3. 3 into 1 is 3 divided by 1 is 3 times 2. 6 minus 3 divided by 3 is 1. 1 times 3 is 3. So this is equals to 6 minus 3. 3 over 3, which is equals to 1. So therefore x equals to 1 and y is equals to 1 over 3. And 3. So given that 3, 0, 1 multiplied by x, y is equals to minus 6 minus 10. Should find values of x, and y. So let's multiply 3 times x is equal to 3x plus 0 times y equals to 0y. So there's nothing like 0y. Okay. And then the next one, 3 times x, 3x plus 1 times y give us y. So this equals to minus 6 and minus 10. So our resulting equation, when we equate rows or entries, equating rows or entries will be 3x is equals to minus 6. 3x is equals to minus 6. So let's call this 1. And 3x plus y is equals to minus 10. Let's call it equation 2. So this is not a simultaneous equation because we don't have another variable here, so we can get the value of x from 1. So let's say from 1, 3x equals to minus 6 and x equals to minus 6 over 3. That's equals to minus 2. So x equals to minus 2. Substituting the value of x into equation 2. We're going to have equation 2 is 3x plus y is equals to minus 10. 3x plus y is equals to minus 10. So we're going to say our x here is minus 2. So we're going to put minus in place of x here. 3 minus 2 plus y is equals to minus 10. So this minus 6 plus y is equals to minus 10. So y is equals to minus 10. Minus 6 come over, cross this sign to become plus 6. So y is equals to minus 4. Okay, so we're going to say therefore x is equals to minus 2 and y is equals to minus 4. So as expressed 2x plus 5y, 2x plus 5y is equals to 3 and 8x plus 7y is equals to 5 in matrix form. So to do that, we bring the rows, the columns to 8 and then the y 5, 7. Since we arrange it like this, this implies that this part is x and y such that we'll multiply 2 times x will give us 2x and then 5 times y will give us plus 5y. Here 8 times x will give us 8x, 7 times y plus 7y plus 5. So that's the way. This is the matrix form of this simultaneous equation. That's how to represent it in simultaneous equation. The number 2 says if 3 1 2 x is equals multiplied by 2 3 and it's equals to y 10. You should look for the value of x and y. So let's multiply 2 times 2 give us 6 and 1 times 3 give us plus 3, and that is equals to 2 times 2 is 4 plus x times 3 plus 3x. This is equals to y 10. So equating rows or entries, we have 6 plus 3 is equals to y and 4 plus 3x equals to 10. Question 1. Question 2. So from 1, 6 plus 3 is equals to y. Y is equals to 6 plus 3. Y is equals to 9. From 2, 4 plus 3x equals to 10. 3x is equals to 10 minus 4. And 3x equals to 6. And x equals to 6 over 3, which is equal to 2. So x equals to 2. Therefore, x equals to 2, y is equals to 9. We're given that 1 k 2 1 minus 1 1 2 5 is equals to 3 5 11 to find the value of k. I think it's supposed to have find the value of k here. And the value of k. So we're going to find the value of k here. So let's multiply. Okay, so we're going to have 1 times -1 will give us -1, and 2 times 2 will give us +4. 1 times 1 give us 1. 2 times 5 plus 10. K times -1 minus k. 1 times 2 plus 2. 1 times 1, k times 1 give us k, and 1 k plus 1 times 5 plus 5. So this is 3, 5, 11, 2. So we have -1 plus 4 give us 3, plus 1 plus 10, 11, minus k plus 2, k plus 5 equals to 3, 11. You will see that this entry and this entry, they are the same with this part of the equation, which is there's nothing to solve for in this area. All we need to solve for is these two entries. So here is 5, 2. So equating entries or rows minus k plus 2 is equals to 5. Cancel equation 1, and then k plus 5 is equals to 2. Equation 2. So from 1 is the same thing, but let's hope from 1 is a k is equals to say minus k plus 2 is equals to 5, then minus k is equals to 5 minus 2, k minus k is equals to 3, and k is equals to minus 3. Let's see what equation 2 will give us. So from 2, k plus 5 is equals to 2, k is equals to 2 minus 5, k is equals to minus 3. So therefore k is equals to minus 3 is the same thing, and that's how it's supposed to be. So that's the answer. Solution. Find a matrix Z, A, B. Find a matrix Z which comprises entries A, B, C, D if A, B is equals to I. Remember that I is identity matrix. So we can also say I is equals to 1, 7, 7. Alright. So meaning that we should get the values of A, B, C, D. Once we get the values of these entries, they will form matrix Z. So let's follow the rule given to us here. A, B is equal to I. So A B is equals to I is equals to A is matrix A is equals to A, 1, 2, B. And matrix B is -1, D, C, 0, which is equals to our identity matrix 1, 0, 0, 1. So let's multiply. A times -1 gives us -A. 1 times D plus D. A times C give us AC. 1 times 0 AC. Okay, that's plus 0 is equal to 0. 2 times minus 1 minus 2, and B times D plus BD. 2 times C, 2C plus B times 0 times 0 is equals to 1 0 0 1. Minus A plus D equating rows or entries. We have minus A plus D is equals to 1. Let's call it equation 1, and AC is equals to 0. So AC is equals to 0 from the equation 2. Minus 2 plus BD minus 2 plus BD minus 2 plus BD is equals to 0. Equation 3. Then 2C plus 0 is equals to 1. Equation 4. So what we can see here is that equation 1 and 2 have A in common, and okay, equation 1 and 2 have A in common. I can start right away by getting the value of C. So I'm going to start with, you can start with any of the equation, but let me start with equation 4. From 4, equation 4, 2C plus 0 is equals to 1. So 2C is equals to 1 minus 0. 2C is equals to 1. C is equals to 1 over 2. So our value is 1 over 2. From equation 2, from 2 AC is equals to 0. But our C is equals to 1 over 2. A1 over 2 is equals to 0. So A over 2 is equals to 0. So A is equals to 0 times 2, which will give us A is equals to 0. Okay, now that we've gotten the value of A from 1, minus A plus D, minus A plus D is equals to 1. Our A is 0, so minus 0 plus D is equals to 1. That's minus nothing, plus D is equals to 1. So from 3 minus 2 plus BD is equals to 0. Minus 2 plus B, D is 1 equals to 0. Minus 2 plus B is equals to 0. So B is equals to, so this minus moves to this side will give us 2. Therefore, A is equals to 0. B is equals to 2. C is equals to 1 over 2. And D is equals to 1. Hence, we come over here. So we say therefore, I say hence, Z. Now the question says find a matrix Z equals to A, B, C, D. So Z is equals to matrix A is 0, B is 2, C is half, and D is 1. This is the matrix Z. Find K if 2, 1, 1, 3, minus 3, minus 4 is equals to K minus 2 minus 2. K we have is multiplying what we have in this bracket. So K here is a scalar. Remember in scalar multiplication has to do with a number multiplying a matrix. So K stands for that number that multiplies this matrix. So let's evaluate. 2 times minus 3 give us minus 6. 1 times minus 4 is minus 4. 1 times minus 3 is minus 3. 3 times minus 4 minus 12 equals to K times minus 2 minus 2K. K times minus 3 minus 3K. Minus 4 minus 6 minus 4 will give us minus 10. Minus 3 minus 12 minus 15 is equals to minus 2K minus 3K. So equating rows or equating entries. Minus 10 is equals to minus 2K. Equation 1. Minus 15 is equals to minus 3K. Equation 2. So from 1, either equation 1 or equation 2 will give us the same answer. So from 1, minus 10 is equals to minus 2K. So K is equals to minus 10 minus 2. 2 here, 1, 5. This 5. So that's equals to 5. Or, so from 2, we have from 2 minus 15 is equals to minus 3K. So K is equals to minus 15 minus 3. 3 and 1 to here 5. So K is equals to 5. If I for x minus 1, 2, y equals to 4, 5, find x, y. Let's get, okay, we're going to proceed by multiplying this matrix by this and equating it to this. So 5 times 2 is 10, x times y has this as plus 10 plus x, y. 4 times 2 is 8, and then 4 times 2 is 8, minus 1 times 5 will give us minus y. This is equals to 4, 5. So equating rows slash entries or entries, we have 10 plus x, y equals to 4. Equation 1, 8 minus y is equals to 5. Equation 2. From 1, 10 plus x, y is equals to 4. So x, y is equals to 4 minus 10. X, y is equals to minus 6. That's equation, equation 3. So let's get the value of y from equation 2. So from 2, 8 minus y is equals to 5. Minus y is equals to 5 minus 8. Minus y is equals to minus 3. And y, right, is minus y is minus 3. So y is equals to minus 3 over minus 1. So y is equals to 3. Now that we've gotten the value of y, we're going to substitute it. Substitute 3 of y in equation 2. So xy is equal to 6. So 3x equals to 6. And x equals to 6 over 3, which is equal to 2. Therefore x equals to 2. y is equals to 2a. What are the values of e in the equations? A squared b minus b, a plus b, e squared minus b equals to 4, 7, 1, 0. So let's equating rows and equating rows or entries. We're going to have a squared equals to 4. So let's say question 1. A plus b is equals to 7. Question 2. B minus b is equals to 1. Question 3. E squared minus d is equals to 0. Question 4. So let's start with equation 1 to get the value of e. So from 1, a squared is equals to 4, and e is equals to the square root of 4, which is equals to 2. From 2, equation 2, a plus b is equals to 7. So where a is equals to 2, so 2 plus b is equals to 7, b is equals to 7 minus 2, which is equals to 5. So 5, so b is equals to 5. From equation 2, question 2 is b minus d equals to 1. B minus d is equals to 1. So b is 5. 5 minus d is equals to 1. Minus d is 1 minus 5. Minus d is equals to minus 4. So d is equals to 4. So from 4, from 4, e squared minus d. E squared minus d is equals to 0. And d is equals to 4. So e squared is equals to minus 4 equals to 0. So e squared is equals to 4. So to get the value of e squared, take square root of both sides. Take square root of both sides. So give us e squared. This square will cancel the square root sign. The e is equal to square root of 4. The e is equal to square root of 4 is plus or minus 2. That's the answer, either plus 2 or minus 2. So therefore e is equal to either 2 or minus 2. So given that x 0, 0, y is equals to 2i, when I is the 2 by 2 identity matrix, calculate the value of root x squared plus y squared. So given that I is identity, so where I is equals to 1, 0, 0, 1. So then you say x 0, 0, y is equals to 2, 1, 0, 0, 1. So x 0, 0, 1 equals to 2, 0, 0, 2. Equating rows or entries, we then have x equals to 2 and y is equals to 2. But we're not stopping here because we were told to calculate this. So root x squared plus y squared is equals to 2 squared plus 2 squared. This is 4, 2 plus 2, 2 squared is 2 times 2. 2 squared is equals to 2 times 2. Means 2 should multiply itself 2 times. That will give us 4 plus 4. So that's equals to root 8. Express root 8 in solid form, we're going to have 4 times 2. 4 times 2, which is equals to square root of 4 times square root of 2. Square root of 4 is equal to 2 times square root of 2. This is equal to 2 root 2. Giving that 2 minus 3, 1, 4, minus 6p is equals to 3 minus 26. So find the value of p. Let's multiply this part. 2 times minus 6 will give us minus 12. Minus 3 times p minus 3 plus, okay, times minus 3p. 1 times minus 6 is minus 6. 4 times p plus 4p. So this is 3 minus 26. Equating rows or entries, and we have minus 12 minus 3p is equals to 3. Let's call this equation 1. Minus 6 plus 4 is equals to minus 26. Let's call this equation 2. So let's from equation 1, so minus 12 minus 3p equals to 3, minus 3p. Okay, let's say collect items. Collect items. Minus 3 is equals to 3 plus 12. Minus 3 equals to 3 plus 12 minus 3 is equals to 15. And p is equals to 15 over 3. So p is equals to minus 5. Let's see what p gives us in equation 2. From 2 minus 6 plus 4 p is equals to minus 26. Now collect the items. Items 4p is equals to minus 26 plus 6. So 4p is equals to minus 20. P is equals to minus 20 over 4. 1 0 5. So p is equals to minus 5. Therefore p is equals to minus 5.